Okay, Saurabh. So now I'm going to start your technical snap on strength of material, and you are preparing for a rights exam, correct? Rights interview.
Yes,
So now tell me first of all how you define strength and how you define material separately.
sir. Sir, first I would define material. Material is anything which we can use to build a structure, and strength we talk in terms of like how much load it can take, how much load it can bear. In that terms, we say about strength.
Or simply you say you just define it is the maximum value of stress that the material can withstand without failure.
Uh,
Correct? This is called strength. Okay, so next, do you know how you define bar? Sorry, beam, not bar.
uh, Beam. Yes,
Yes.
sir. So, sir, beam is a structure uh, which can take vertical and horizontal loads, and it is it is a horizontal structure that is supported on columns and different supports.
Okay, so you just define beam is a structural member which is subjected to transverse load, correct? Beam
Yes,
is
sir.
a horizontal structural member which is subjected to transverse load, that is called
Sir,
beam.
yes,
Okay,
sir, it can be axial loads also can be there.
no, no. Beam is especially designed for transverse load bearing capacity, correct? ट्रांसफर
Uh,
लोड को बियर करने के लिए डिजाइन किया है नॉट
yes.
नॉट फॉर एक्सियल लोड
Okay.
करेक्ट
Okay.
फॉर
Yes.
एक्सियल लोड we provide bar. Okay, what do you
Yes.
mean by flexural rigidity?
Sir, flexural rigidity is defined to see how much the beam, how much the structure member is can bear a uh, can resist bending. So in that term, and it is denoted by EI. So to see that how much rigid member is with respect to bending, we define flexural rigidity.
Okay, let us suppose you have higher flexural rigidity. It means in
Sir,
terms of movement of resistance.
Sir, if it have higher flexural rigidity, then it means that the beam can take more load. Beam can take more moment.
Okay, and what do you mean by section modulus?
Sir, section modulus is defined as moment of inertia about neutral axis, and divided by the maximum distance of the topmost point or bottom point from the neutral axis. And it also
Mm-hmm.
represents the strength of cross section. So it is the main term it is the main uh, property which we keep in
Hmm.
mind while designing a beam.
Okay, so for beam design, the section modulus should be higher or lower.
So section modulus should be high.
Should be
Uh,
high.
yes, sir.
And let us suppose you have rectangular cross section and I section. Then which one is preferable?
Sir, we would prefer a I section as it have more material towards the away from the neutral axis, so its I is more, and that results in more section modulus.
Okay. And what do you mean by beam of uniform strength?
Sir, a beam of uniform strength is the beam for which the maximum stress for which where member is uh, where the stress at every point is the permissive maximum stress that it can take. So it will have varying depth so that at
Hmm.
every point it is taking maximum permissible stress.
Okay. So have you seen the some in some small bridges, the cross section is or you can say if you see its front view, then it is made up of in an arc shape. correct?
Yes, sir.
Why we make this shape? Why not flat or rectangular shape?
Sir, arch shape, sir, we design an arch shape because uh, then the bending moment get reduced for the whole of the member, as there will be a horizontal force, and at every point, if we take the bending moment, then a negative component from the horizontal force will come, and that will reduce the bending moment for each section.
Okay, okay. And how you define column?
Sir, a column is a vertical member uh, to resist load.
Which load?
Sir, it can resist axial load, and there can also be axial moment. There can also be moment in there can also be uniaxial or biaxial bending.
Actually, column is only designed for buckling. Means, sorry, column is only designed for compressive load, correct? Not for bending moment. Is it
Uh,
clear? And
yes,
while loading, while applying load, we must ensure there is no tensile stress. Is it clear?
yes, sir.
Correct. So it is only possible when your load is acting on the column in a certain region. And what is the name of that region?
Sir, please pardon.
Suppose some when you apply load on the column, axial compression load on the column,
Yes,
then
sir.
sometimes we have some eccentricity. Is
Yes,
that
sir.
clear? So at what region first the eccentricity is allowed, and what is the name of that region?
Sir, that we can call as current section. If
Mm-hmm.
our eccentricity is within the current section, then it ensures that no
Mm-hmm.
tension force will come in the column member.
Mm-hmm.
And
And suppose let us suppose you have rectangular cross section.
yes, sir. Sir,
Width is B and depth is D. Then how much eccentricity is allowed?
sir, eccentricity allowed is B by 6 and D by 6 on both sides. And
Okay. And what do you mean by slenderness ratio?
sir, slenderness ratio is defined as effective length by the least lateral dimension or effective length by the least radius of gyration.
Okay. And how you define effective length?
Sir, effective length is the length between two point of contraflexures.
Okay.
Uh,
Okay. Now let's see some question from combined stresses. Correct.
yes, sir.
So let us suppose you have a biaxial state of stress in which both stresses are in equal magnitude and opposite in nature. Then what type of Mohr circle you will get?
Uh, sir, please pardon. I didn't understand like which section the
Let
course.
us suppose you have biaxial state of stress
Yes,
with
sir.
equal in magnitude.
Okay, okay,
Means both stresses are equal, but both are acting in opposite direction.
okay, okay. Yes, sir.
Correct?
Yes, sir. Sir, are there any shear stresses?
No shear stress. Okay. And also locate how where the principal plane is located at what angle. Means you need to represent 2 theta p location of
Sir,
principal plane. Correct?
sir, and shear stress is not present there, so these are the principal stresses on which the stress is acting.
Which
Sir,
one?
only
You just name it.
sir, A and B point represent the.
Actually, it is not visible. I think you made blur. Correct?
Yes, sir. I
Your
will have.
setting.
Uh, Yes, sir.
So
Sir, A
which
and
one is
B.
principal plane?
Sir,
A
A and
and
B
B.
point.
And what about 2 theta p?
Sir, 2 theta P.
Hmm.
Sir, 2. Uh, sir, sir, 2 theta P is. Sir, sorry, sir.
And what is the value of maximum shear stress on zero normal stress plane?
Sir, it is sigma only.
Okay. And, and let us suppose you have a pure shear state of stress, then how you draw its Mohr circle?
In case of pure shear stress. In this second figure.
Now tell me, in this where you have principal plane and what is the value of 2 theta p?
Sir, principal plane is at 45, will be at 45 degree with the shear stress plane on which shear stress is acting. And here it is represented by the horizontal axis.
So in between these two axes you have 45-degree angle.
Yeah, yes, sir. In the plane, in the body.
Actually, this is 90-degree, correct? And this is 2 theta p. In Mohr circle, we always represent all the angles in 2 theta form, correct?
Yes, sir. So here it is 90 degree.
Correct.
Yes.
And obviously, when you represent theta p, then it will be a 45 degree,
Yes, sir.
correct? Okay.
Yes.
And okay, one more question. Suppose if you want to design your beam on the basis of dynamic condition, then how you design?
Uh, Beam designing on the basis of dynamic condition.
Hmm.
Sir, sir, sorry, sir.
Okay, what is the application of deflection of beam? Why we study this chapter?
Sir, we study deflection because we should know like when the loads will be acting, how much deflection will come in the member, so we can know that how much permissible loads we can apply on them.
Anything else?
So like we study in the limit state of serviceability, that deflection should be limited. So we have to read the deflections like which load will cause what deflections.
Actually, deflection in topic is necessary because we need to use this concept for design of beam under dynamic loading first. Second, it is used to solve indeterminate problems, correct?
Yes, yes, sir.
And third, and it is also used to design the beam under rigidity criteria,
Yes, sir.
correct? How you use? Obviously, when with the help of this deflection, we get some more equations, yes or no?
Yes, sir.
Let us suppose you have a fixed beam. Then obviously it has, if it is subjected to vertical load only, then it has four unknowns, yes or no? But actually you have only two static equilibrium equations. It means you need two more equations, yes or no? And
Yes,
those
sir.
equations can be obtained by using deflection. So by the use of deflection, you can easily solve that problem,
Yes, sir.
correct? And similarly, from deflection, first you get deflection, maximum deflection, and that deflection should be within the permission limit. And on the basis of this, you design the beam under rigidity criteria. It means higher, lower will be the deflection, higher will be the rigidity, correct?
Yes, sir.
And similarly, if you want to design your structure, let us suppose your building is, if you need to design a building which is lying on earthquake zone, correct?
Yes, sir.
So on that condition, you need to determine how much frequency, natural frequency of your system or your structure, correct? And
Yes, sir.
एक तो ये पता होना चाहिए कि उसका स्ट्रक्चर में आपका नेचुरल फ्रिक्वेंसी क्या है, करेक्ट? एंड जो आपका वाइब्रेशन प्रोड्यूस हो रहा है दैट शुड बी विद इन द रेंज और इट एक्सीड्स, करेक्ट? अगर विद इन द रेंज है तो ऑब्वियसली योर जो स्ट्रक्चर होगा वो सेफ होगा। एंड कैसे पता करोगे नेचुरल फ्रिक्वेंसी? बाय यूजिंग स्टैटिक डिफ्लेक्शन मेथड, ओमेगा एन इज इक्वल टू रूट जी बाई डेल्टा, करेक्ट? So with help of
Yes,
this you
sir.
can determine natural frequency of the system. So these three are the major application of deflection of beam. That's why we study deflection of beam, correct?
Okay, sir. Yes, sir.
Are you getting this point?
Yes, sir. I did
Okay,
just
Saurabh, so now I'm going to conclude.
yes.
Yes, tell me.
I did get that dynamic part like natural frequency G by delta. I
Yes.
I read it. It's K by.
You don't know it?
Sir, I read it. It's
Okay, by delta only.
okay. Okay.
Okay. Okay, okay. You just leave it. You just remember this, correct?
Yes, sir.
आपको बहुत ज्यादा इसके बारे में समझना कि इतनी नेसेसिटी नहीं है, बस पता होना चाहिए कि व्हाट इज द एप्लीकेशन ऑफ दिस, दैट्स इट,
Yes, sir.
करेक्ट? ऑब्वियसली आपने पढ़ा होगा ना अर्थक्वेक रेजिस्टेंट बिल्डिंग, हाउ टू डिजाइन अर्थक्वेक रेजिस्टेंट बिल्डिंग,
Yes,
ऐसा
sir.
कुछ कॉन्सेप्ट पढ़ा है कहीं भी?
Yes, sir. It was there, but only it was single degree of freedom, and we studied.
सिंगल डिग्री ऑफ फ्रीडम, तो वहां पे नेचुरल फ्रिक्वेंसी फाइंड आउट किया था कि नहीं?
Yes, sir.
बाय
Yes.
यूजिंग टक्करली मेथड, स्टैटिक डिफ्लेक्शन मेथड,
Yes, sir. We found the
करेक्ट?
stiffness and etc. Yeah.
ओके, ओके सौरभ, so now I'm going to conclude your interview. Your most of the topics are completed, correct? You have prepared, and you need little bit more improvement, correct?
Okay, sir.
Like when I ask in Mohr circle, you represent 2 theta p, then you hesitate to give the answer, correct? And similarly, some more, if I talk about, and साथ में मैंने आंसर आई थिंक बताते भी गया हूँ ना, जो जिन क्वेश्चन के क्वेश्चन आंसर नहीं बने थे, करेक्ट है?
Yes, sir.
तो
You told
एक
about
बार
2
उसको,
theta B dynamic.
तो ये कुछ चीजें हैं जिनको आप एक बार देख लो, बाकी रेस्ट इज ओके। एनीथिंग एल्स?
And sir, one thing like how will you design beam for dynamic loading?
यस, वही सेम नेचर, यू जस्ट डिटरमिन नेचुरल फ्रीक्वेंसी ऑफ द बीम एंड दैट द सपोज जो स्ट्रक्चर आपने जहाँ पे बीम को यूज किया है वहाँ पे जो वाइब्रेशन प्रोड्यूस हो रहा है, इफ दैट वाइब्रेशन विद इन द लिमिट आपकी नेचुरल फ्रिक्वेंसी से कम है, देन ऑब्वियसली जो स्ट्रक्चर होगा वो सेफ होगा, है कि नहीं? एंड
Oh,
इफ इट एक्सीड्स
yes, sir.
देन ऑब्वियसली फेलियर हो जाएगा। देन आपको पता करना पड़ेगा कि जिस जिस लोकेशन पे आप सिस्टम स्ट्रक्चर को डिजाइन करने जा रहे हो, वहां पे अगर सपोज अर्थक्वेक भी आ रहा है तो वहां पे कितना वाइब्रेशन प्रोड्यूस हो सकता है, या विंड आ रही है उस विंड से कितना वाइब्रेशन प्रोड्यूस हो सकता है, कितनी डायनामिक लोडिंग लग सकती है, ये सर नो,
Yes, sir.
करेक्ट है?
Yes, sir.
और फिर उसके अकॉर्डिंग हम डिसाइड करेंगे कि हमारा जो सिस्टम है उसका नेचुरल फ्रिक्वेंसी क्या होना चाहिए, उसके लिए हमारा शेप एंड साइज क्या होना चाहिए,
Okay,
करेक्ट?
sir.
ओके,
Yes, sir.
चलो ऑल द बेस्ट, थैंक यू।
Sir, I one more thing I want to ask, sir. Like, is BMCT important for rights?
हाँ हाँ, वाई नॉट, थोड़ा थोड़ा सा आइडिया होना चाहिए ना ऐसा। मैंने कहा ना, इससे रेलवे से रिलेटेड जितने भी टॉपिक हैं, है ना, वो सारे टॉपिक आपको आइडिया होना चाहिए कहीं ना कहीं।
Sir, if I study cement and the tests in that, sir, will it be okay?
Yes, 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 why not? This part is okay. And you also read some materials which are used for making structure
Okay, okay.
and their properties, correct?
Yes, sir.
And you also read how to perform various tests to determine their structural uh, characteristics, correct?
Okay, sir.
तो ये कुछ बेसिक चीजें होती हैं, वो तो आपको पता ही होना चाहिए एज ए सिविल इंजीनियर, करेक्ट।
Okay, okay. Yes, sir. Definitely.
बाकी जो आपने कुछ पढ़ रखा है उसमें तो ठीक है, कोई इशू नहीं है। और स्टील के लिए मैंने आपको बता ही दिया कि थोड़ा सा उसके बारे में आइडिया ले लो। और बस हो गया।
सर, इसके अंदर
और
मैंने रिजिडिटी वाला
थोड़ा
आंसर सही किया था क्या?
और हाँ, रिजिडिटी आंसर सही था। ठीक है,
ठीक, थैंक यू
चलो,
सर।
ऑल द बेस्ट।